Hi all, Mr. McRae here, doing another video. This time I'm doing it on um, Pythagorean theorem with coordinate points. Okay, so we talked about Pythagorean theorem last week, and that it's only with right triangles, and if we have the lengths of both sides of legs, we can find the other missing side. So we knew what the equation was: a squared plus b squared equals c squared. So what we're going to do is we're actually going to look at this do now question I did, and we're going to find the distances between the 3 points shown, and that's going to really unveil to us how to determine the Pythagorean theorem with the coordinate points. Okay, so let's look at the first one. All right, so we have the distance. We have to find the distance of these legs, A and B. So we know this is going to be A, and this is going to be B, and you obviously know what this C is going to be, the hypotenuse. So we identified that information. Okay, so let's determine this. So how would we find the value or the distance between negative 14.9 and negative 14.3? So what do we know? Remember before, if we find the distance between something, it was always a change in y over change in x. So if we look at it here, we have negative 14 and negative 14. So that means it's on the same parallel line. So therefore, all we would have to do is basically that would eliminate those two values, and then we would just have to take the y value and we'd have to minus them. So we take 9 minus 3, and that turns, because that turns to positive, so that would be 12. Okay, same thing on the bottom here. We have negative 3 and negative 3. It's on the same line, but so we have to just count horizontally how many spaces to get to 16, from negative 14 to 16. So again, we can do 16 minus 14. We know if we add, we got to put a plus here, and that gives us 30. Okay, so that would be 30 right there. All right, so again, we have A is equal to 12, B is equal to 30, and then now the problem is C. How do we find this one? Now, we could do it the old way if we wanted to. Okay, we can do A squared plus B squared equals C squared. So we just square both values and then square root that number. So we've done that before. Okay, so basically what we look at if we do that without the work is this: square root of A squared. Okay, we have the square root of A squared, okay, plus B squared, okay, and that's how it would look. All right, because that would give us a value of C. So with the coordinate points, however, though, we don't, a lot of times we won't have the value of A and B. We just have to basically use the coordinate points to help us find that information. So let me give you the equation to do that. All right, so it's the same thing as slope, but just we have to do one thing. Instead of dividing the values, we're going to add those values together like we do here, and basically we're going to square root. So so C would equal to, okay, we have the square root of x squared minus 1. Okay, so we found the distance there, squared, plus y squared minus 1 squared, that. So that's how you would find the distance of the hypotenuse. Okay, and thing you need to know about it is basically because it's a diagonal line, it doesn't go on a flat plane. If we went on a flat plane, we can just count the number of spaces, like kind of like a board game. Okay, so if we go 14, keep going down till we get to 30. Same thing on the horizontal one as well. But this one is diagonal, so you really can't count like that. All right, so let me do this. So basically, we're going to take y2, which would be, I'm going to take 16. I'm going to minus that from y1, which is 14. Okay, I'm going to square that. And then I'm going to do the same thing here, okay, which is negative 3. I'm going to minus that from 9, and that's going to square that. Okay, and that's going to give me C. So then from there, all I have to do is just do the math. Okay, see where it comes, the positive negative integers come back, square roots, exponents, all that stuff that we did in the beginning for foundational stuff is all starting to come back into our regular math concepts. So as you can see, so just be prepared. That's why we're doing all that work. Okay, so if we got this 16 plus 14 gives us 30. So 30 squared. Okay, 30 squared. And then we have, okay, we have 30 squared. Then the other one is basically, I apologize for that. My mom just turned on the TV, so it was kind of loud there. So this would be 12. Okay, so negative 12 squared. Okay, and then put it over square root. Then we got 900 plus 144. Okay, and that gives us 1044. And then we square root that. So if we do that approximate value out, that would give us 32.2. Okay, and so that would be the value of this, okay, of C. Okay. So one thing I want you to notice though, how do I can check to see if this is right? Okay, that's the question I want to ask. How do I check to see if this whole lengths work with each other? Okay. This is the thing about this is if you have a value, say a squared plus b squared equals c squared, okay, they should add to each other. So both legs, if you multiply both, if you square both legs, they should that equal the value of the squared c as well. Okay, so you think about it. Okay, so if we square 30 and 12. Okay, square root 2 at 12. Nah. Okay, that's going to equal to 900. This is going to equal 144, and that's going to be c squared. And then from there, that add those together, it's equal 144, and that's going to be, and then we square root both sides, and that's going to be 1044. So again, what happens is the values of a and b added together should equal c. Okay, so the values of a and b added together, square rooted, should equal c. That would be the value of c. Okay, so that's the idea. So if they can add these two together and they can equal the c value, that you automatically know that you got the right answer. Okay, I know that's a lot of information, so let's practice a little bit so we can see it more and more in depth. So what I did was I actually took out, and I'm only going to do, most of the time we're only going to do the hypotenuse portion of this equation so we can practice those little coordinate points distances, and then we'll start working more into doing the other stuff as well. So hopefully you didn't hear that. Okay, so let's try another problem here. All right, I know this is kind of difficult. So basically we're going to find the distance of each point. Okay, so we have P1 here, that's 1 point, and then we have P2. So we have to find the distance between both. So one thing we did say though, since it's diagonal, you just can't count the spaces. If we can count the spaces, that would be easy, but this is diagonal, so you can't. So first we got to figure out what the coordinate points are. So this one is 3, and what is this one? 3 and 4, that's 1. This one is -4 and -2. So we have those 3 coordinate points. All right. So we have 3, 4, and then we have -4, -2. Okay, so this would actually be x1, and this would be y1, and this would be y2. I'm sorry, x2, and this would be y2. Okay, so again, we want to look when we label our points, we want to look left to right. So here's our equation. Okay, here's our equation. All right, so we have x2 minus x1 squared plus y2 minus y1 squared. Okay, so that would be the equation. So let's plug the values in. So we have 3, okay, and then we minus that from -4, square that. Then we have y2, which is 4, and we would minus that from -2, and then square that, and that would be the value, okay, and then we square root the whole thing. Okay, so let's do that out. So this is plus plus, so that's 749 plus, okay, we have boom boom the 636. Okay, and then square root that. So we add these together, we're going to get 85. Yes, so we need the square root of 85, just like that. Okay, so the value of this would be the square root of 85. Now, if you want to break that down, that'd be great, but I'm not dying over that. If you can, that'd be great if you can do that, but if you can't, that's fine. You can 85 goes into 5, how many times? I think 13, if I remember correctly. No, more than that. Let's see. 17 times, not really worth it breaking down. So other way you could do it is just you can just take the value of it, and actually would work out to 9.21. Okay, and that's be the value of this one right here, 9.21, the length. Okay, bunch of ways you can do it, but again, like I said, basically again, x2 minus x1 squared plus y2 minus y1 squared, square root on the top of it. Okay, and that will help you get your answer. All right, so let's try another problem. So here's a little tougher. Now we have something similar to what we did in the top here, and now we're gonna use that. All right, so now we have to find the distance of each one. Okay, on your homework, on your weekly exit ticket this week, it's also mostly just going to be finding the distance and the perimeter around each one. So that's where we're going to end up going to a little bit, is finding the perimeter, just to give you some more practice, but of multiple step problems. Okay, so let's look at these here. So we have the distance. We have to find the distance of each leg. So this is A, this is B, and this is C. Thousands ways you can do it. Again, once you find the distance A and B, you can use the Pythagorean theorem to find this, or you can just use the theorem of distance formula I just gave you to find the length of the hypotenuse. Bunch of ways you can do this. So what's the distance here? So let's see. We have 2 and 2. Okay, we have 3. We have 8 and 5. So we have to find the distance. A would be 3. So 8 minus 5 would be 3. Here, okay, we have 8 and 8. So it's on the same playing field, but now we have 2 minus 8. So it'd be 2 minus negative 8, and that turns to positive, and so that would be 10. Okay, so we'd have a value of 10. So B would equal 10, A would equal 3. Okay, so bunch of ways you can do this. Again, you could use A squared plus B squared equals C squared. Okay, and remember what we said the rule was: if it's like that, then we're going to square root A squared plus B squared. So then you can just take 3 squared and 10 squared, and then that would give us 109. So square root of 109. 109. Okay, and 109, I think the square root of the, God, tough number. Okay, 109. I don't think it breaks down any. Actually, I don't think there's any values that would work for that. So that's why it's tough. All right, so 109, the approximate value of that, again, use your calculator, okay, would be 10.44. Okay, so that would be the distance of that, 10.44. Okay, I can check that. Now, again, let me show you the other way of doing that to find C. All right, just take the coordinate points. Okay, A squared minus 1 squared plus y2 minus y1 squared. Okay, boom. Now, just do the values here. Okay, so we have x2. Remember, go left to right on your x's. Okay, so this would be x2, y2. This would be x1, y1. Left to right. So, okay, so this would be 2 minus negative 8 squared. Okay, square the whole thing. Okay, and then we have y at y2 would be 5 minus 8, and square that bad boy, and then square root the whole thing. So add 10 to that, that would give us 100. Okay, negative 3 squared is 9. Okay, it's not negative 9, it's positive 9. So again, square root of 109, which is 1044. Okay, so again, two ways you can actually find this. I like this way because, again, it just works easier, because a lot of times is you won't have to find the legs. You're probably just going to have to find the hypotenuse of this and the length between these a lot of times. So again, make sure that you kind of understand the idea of this. All right, so let's try another problem. This is the last hard one we're going to see. All right, this one's actually kind of doozy. All right, so now we have three sides, but now all three sides are not, they're not horizontal or vertical. They're all diagonals. So now we have to find the distance of each side. Okay, so they know, because again, this is not a right triangle. So this is the great thing about using the distance formula. You don't have to have a right triangle to use it to work it. Okay, so again, the equation was x squared minus x1 squared plus y2 minus y1. Square that bad boy. All right. So let's take A, this is B, and this is C. We can still label it the same way, but we just know that it's not. So let's do A first. Okay, so A would be, and then A would be first, we'd have, this would be x2, this would be y2, this would be x1, this would be y1. So x2 would be 9 minus 7 squared plus, okay, and it would be 2 minus 4 squared, and to put that over a square root. 2 give us 4, okay, negative 2 gives us another 4, so this would be 8, so it would be square root 8. Okay, this would be square root 8. Now square root 8 will work out to be 2 square root 2. All right, so we know that because the square root of 4 times square root of 2, and this turns into 2. So this would be 2 square root 2. Okay, that'll be the first one. okay, or square root 8, whatever you want to do it. Okay, next one. So this one would be left to right. So this would be, that would be x1, x2. So this would be x1. This would be y1. Oops, sorry guys. This would be y1. All right, so let's do b. Same thing. Okay, so we have x2 is 9 minus 8 squared. Okay, plus this would be let's see, negative 5 minus 2 squared. Okay, so this would be 1. This would be 1 plus, okay, this would be negative 7 plus is 49. Okay, square root 50. Okay, so at that one, this would be square root 50. Or if you want to break this down, this would be 2. Yeah, it would be actually be the same thing. 2 square root, no, 25. 5 square root 2. This would be 5 square root 2 because this is 25 and 2. So this one would be 5 or 5 square root 2. Okay, so that's how that one would work. Now, so again, what we can do is, now if we square both these values, we should end up with c right here. Okay, so we can just we can square root 8, 2 and 8. We should have to end up with the square root of 58, I think. That's what I think we should end up with, the square root of 58, if I remember correctly. All right, let's do this one. Let's do c. Okay, so c again, we'll do, so this is x1, x2, because this is left. This would be x2 now and y2. So let's do 8 minus 7 squared, okay, plus y2 would be negative 5 minus 4 squared, and square root the whole thing. So this would be 1 plus 9 would be, this would be 9, 81. Okay, I think it would be, yeah, 81. And then we would add these both together, okay, and that would be square root 82. Make sure I got that right. Negative 4. Yeah, negative 4. Yeah, that's right. Perfect. Okay. All right. So there'd be square root 82 in this answer. Okay. And square root 82, I think that breaks out to be 2. No, you can't break it up with 2's. 4, 21. So 2 square root 21. No, that wouldn't work either. So just keep it square root 82. So the value of this would be square root 82 as well. Okay, so again, like I said, you just basically have to use the distance formula for all three sides if you have an irregular triangle like this, and that would definitely help you to get that information. Okay, so again, this might be a little difficult. We'll have a couple days of practice on this. I understand this might be a lot, but sometimes we have to really push ourselves to get multi-step problems and kind of work ourselves through it. Once we get back to school, we'll start. I can be able to help you guys that are in school 101 to try to get this stuff done and get better at it. Okay. All right, now, guys. Bye.